About my presentation. Previously, people have been talking more about how to actually sense the motion of human bodies and etc. But my talk will be more about how to actually sense the motion of excavators and other large machines. So, first, I will give you a presentation about the company, what we actually do. It's probably not so familiar to most of you. Then I will talk to you why we actually need to do motion sensing for excavators, what do we actually benefit from it. And then I will move on to how we actually do it, and finally I will give you a sneak peek of the future of machine automation for excavators and other large machines in our view. But it's a good idea after lunch to start up with a video. So let's hopefully after this video you will at least have some kind of understanding on what Novatron actually does. So hopefully this has some sound. Okay, so on the video, you saw the machine excavator operator working with this large display in his machines. On that display, he was able to see the actual 3D model of the ramp that he was building, and he was able to see the machine and the bucket moving in the real-world coordinates relative to the actual 3D plan of that ramp that he was building. So that's basically the whole key that what we are currently doing. So the idea is that the machine operator would always have the information that how he should actually build the, or what and how he should actually build the construction that he is building, so that he can always see where the bucket is actually moving relative to the plan. So that traditionally this work of measuring that how the work had actually been done and how accurately it has been done was done by land surveyors. So basically men with measuring sticks and laser measurement devices coming after the excavator to actually do measurements of the actual surfaces and if something was actually not correct, they would just tell the excavator operator to how to actually make it correct, that you need to actually fill this area with 10 centimeters more sand, or take 10 centimeters out from this area. So with our tools, this part can be basically left out, and the operator can directly do the work accurately. So we are also nowadays part of German-based MOBA group. And as I said, our core competence is in digitalized earthmoving and automation of mobile machinery. Our solutions, they include the actual machine control systems, but also, of course, the hardware, software, and also the services related to those. So we also offer free services for the people buying our products. So basically, the excavator operators always have a direct and free contact channel to our Novatron help desk, and they can actually help them in some cases if there is something wrong with the system or something wrong with the 3D model itself. We sell our products to individual contractors, but also to the machine manufacturers and municipalities and other players on the area. So, some facts about MOBA. So, Novatron is partly owned by MOBA, but mostly still owned by the family who started it up. The MOBA itself, it was started 72. Well, you can see the figures over there. It's a German-based company, and it has 18 different daughter companies around the world. Roughly around 600 people working for them. Their business segments are here. They basically started their work from the road construction site, or road construction. And there are roughly 20 manufacturers for road paving machines in Europe. And MOBA is supplying 90% of those with the blades that make sure that the asphalt layer is at the right thickness and it's leveled enough. Second segment is the waste management, where they, for example, supply services so that they can automate the billing procedure for the waste management, so that the waste management, or you don't actually have to pay for the empty bins that the waste management come and empty, but you only pay for the amount of waste you actually produce. So they include the measuring for how much waste has actually been produced. Third one is cranes and lifters, and the fourth one is earthmoving. And the earthmoving segment is basically Novatron. So Novatron is MOBA's earthmoving expertise. And well, and here are some facts about Novatron. So it was founded in '91 just by one man, and so it has over 25 years of experience in developing machine control systems. We are based in Finland, in Pirkkala, as was told. And in Pirkkala, we still have our main office space, but we also nowadays have offices in Oulu and Helsinki. Novatron has actually been growing at least for the 5 years. For example, well, nowadays there are 100 people working for Novatron, or over 100 people, but just 2015 there were only 40 people working for Novatron. So just in 4 years the amount of people has actually doubled. And also one interesting fact is that almost 1/3 of our employees are actually working on R&D. So we are heavily investing in the research side of development. And just to give you an idea where everything actually started with, On the left side, you can see the, well, not the first product, but one of the first products provided by Novatron, which is the depth measurement device for excavators. So basically, this does the similar kind of stuff that the new system, but just showing one figure. So this shows the depth, how deep the excavator operator is currently digging. And for this one, he can only set levels, basically. So some level, and then compared to that level, how deep he is currently digging. As you can see, only had one button for zeroing the level. Then the second version on the right side, improvement. Now there is two buttons actually. One for zeroing the device and one for memory. But actually, I've been told that Novatron actually got quite a lot of complaints because of this one because the operators were saying that this one was too complicated to use. So, well, nowadays we have 3D systems and so on, so we have gone quite a long way from here. So, globally, we are currently concentrating in the Northern Europe, mainly also because the digitalization of earthmoving is growing largest in these areas currently. Elsewhere in the world, where we are sold, we are part of MOBA brand. So we are basically in Northern Europe, we are still known as Novatron, but in the rest of the Europe or in the world, we are known as part of MOBA group. And our business segments include the digital infrastructure construction, which is basically the machine control systems that you already saw. Then the second one is automation of mobile machinery. I will show you some examples at the end of my presentation also. And then the third one is the actual OEM components that we are building, actually in or developing and manufacturing in Pirkkala. So that basically includes the sensors and controllers. For example, the G2 IMU that we are using in our control systems. So, that's about the company presentation. Then I will move on also towards why we actually need motion sensing for excavators. I have already given you a couple of examples how the excavators drivers work, but here is a video showing hopefully also how the digitalization and so on, also the motion sensing will help actually the whole process of construction.
Novatron, earth-moving automation. Since the early 1990s, Novatron, a part of the MOBA group, has been a forerunner in the field of earth-moving technology. Back then, it was all about machinery and manpower. Information technology was taking its first steps, and the idea of machines communicating with each other was just a dream. As digitalization continues to push societies towards all smart systems, the construction industry in general remains almost untouched by digitalization. But now, the hard and dirty work of earthmoving is itself under construction. With new possibilities provided by digitalization, robotization, and innovations in technologies, our pioneering solutions increase the productivity and quality of earthmoving to new levels, while making the work safer and more sustainable. Our offering covers everything from robotizing heavy machinery to digitalizing job site processes, and our proven systems and strong focus on open BIM benefit all stakeholders. Join the smart future of earth-moving automation. We have the knowledge and solutions to take you to the next level.
Okay, so about digitalization. What it basically all comes into in earth-moving industry is BIM models, so Building Information Models. Basically, it means the life cycle management for the built environments. For example, usually when you start or we start building something out of nothing, first we need to gather the source information of the area where we are actually building the roads or buildings, which means that we basically need land surveyors doing measurements on the site, or sometimes we need 3D laser scanners to actually scan the area, or we might need to do some kind of test drills of the area to actually see what is under the soil. So that basically gives us the source information where the designer can actually start designing the actual model and the production, how the construction should be built. So the designer will actually decide what kind of layers there will be, if there needs to be multiple gravel layers, for example, if there needs to be where the pipings needs to go and so on. So basically he develops the 3D model and the sequence of how the site should be built. Then this infra-BIM model will be passed on to the constructor. So basically the 3D design built by the designer will be shown to the excavator operator on our screens. So basically that is the information that is going from the designer to the construction site. So at that point, again, the excavator operator can directly see on his screen how the actual 3D model is looking at. So he can directly see what he should be actually doing. He can see all the different layers related to that, which layer he should be working on, what kind of layers he needs to be doing next. And of course, he can also see the work, how he is actually doing the work currently relative to the actual plan. And sometimes, of course, there might be also some complications. There might be on the construction site, there might be extra sewering pipes or something like that found, which are not part of the plan and were not actually found from the source data. So in that case, the infra-BIM also gives the possibility to actually send the information back to the designer. So the machine operator can actually directly on his screen save the location information of the endpoint of the bucket, which basically means that if there is some sewer pipe found from the site, the excavator operator can just place the bucket on top of that sewer pipe and just press one button on our display, and the information is actually saved on the infra-BIM model that the designer can then see directly from his screen. So he can directly have the information what was actually found on the work site and where it was found. And then the designer can of course redesign his work, and that the model is then again updated to the construction site. So this whole digitalization brings that kind of benefits, and it shows where does our products actually come in. So also when we are building, we also need to verify how we have actually built the whole construction site. So again, traditionally there would be land surveyors with laser measurement devices, measuring sticks, so on, to actually measure what the end result actually looks like. But again, with our tools, we can just place the bucket at the level of the surface, and we can just save the information what is the surface of this layer currently. And that information is saved into the infra-BIM model. So again, no extra need to do extra verification work. So then, when everything is basically done, the maintenance crew or the maintenance will have the information of how the actual work site was supposed to be built and how it was actually built. So both information. And again, if something actually needs to be changed in the future, there will be no need to actually gather new source data, but there will be already the information from the previous round for all the necessary information. So, what kind of hardware is actually related? You can see that, of course, we have the 3D, or we have the display showing the 3D material. We have the control computer, and then we have GNSS devices for actually getting the information of the position of the excavator in the real world. Then, to actually calculate the position of the bucket, we use our own IMUs, which will be located in the frame, boom, arm, and bucket of the excavator. So basically, we will have the kinematic link from the GNSS poles all the way to the end location of the bucket. That basically gives us the information what we need to actually do our work. Then in some cases, we might also need to have laser receivers for which actually can do the 2D laser measurements of the level, but that's a bit different story. As already told by previous presenters, I guess you are already familiar with GNSS, but I will just give you a small presentation of how the disturbances of the GNSS actually affect our work. So basically, the GNSS signal itself is, if we try to make our measurements just based on that, the accuracy is within meters. If you actually want to get within centimeter accuracy, then we need to use RTK GNSS, which basically means that we have a correction signal telling us what kind of disturbances are affected by this GPS. So there can be, for example, atmospheric disturbances. Sometimes there is some obstacles actually on the way, stuff like that. But the most, what RTK GNSS can fix are the atmospheric disturbances. For example, there can be a base station on the worksite provided by us, and basically that location of that base station is known. And when we know the location of that base station, we can recalculate that the base station should actually be here, but the GNSS data shows that it's actually shown in here. So all the GNSS devices in that worksite, we need to redo this basic mapping from this place to this place. So actually the correction is also location related, and that's why sometimes you might need a local base station at the worksite. There are also correction signal providers in Finland that cover basically the whole area of Finland. But in some cases, that correction signal might be, or it might not be good enough for actually getting the accuracy that we need, and in that cases, we might need the local base station. So what does our product actually look to the excavator operator? On the left side, you can see a view of a layer that the operator is supposed to do. And you can see that the excavator is shown on top of that pile, so the excavator operator has already done something like that in the real world. So he is already trying to make the actual model of the surface. So there is a 3D view of the whole area with the 3D model of the plan. But then in the lower sections, you can also see closer information of where is the bucket actually relative to this plane that he is actually trying to build. So from this view, you can see that the operator can quite easily see how he needs to correct his bucket to actually get correct results. For example, right now it shows that it's, the bucket is 14 centimeters below the wanted surface, so it's quite easy for him to actually fix the error. On the right side then, you can see actually a bit more complicated example, which probably shows a real-life example, because it actually shows multiple different layers on top of each other. So the actual model would look something more like in the right image, and on that image the excavator operator would then just need to select which layer he or she is actually working with currently. Well, I've been talking about excavators, but our systems will also be available, or are also available for other machines. For example, the drilling rigs, where you can, or the machine operator can navigate to the next drilling hole, and they can also save the information of the depth of the drilling holes and so on. Rollers, where the operator can see the pass count, how many times he has actually passed one segment of the area he is supposed to roll over. Because quite many times the designer actually designs the layers so that a layer needs to be passed 5 times with a roller so that it's compacted enough. If it's too compacted or not compacted enough, it's not good enough. So basically they need to do quite exact work to actually get good compaction results. Then others, loaders, dozers, telescopic boom excavators, which are not that common in Finland, but at least in Europe they can be found. And then dredging rigs, which is ruoppaus in Finnish. Okay, so that's about our products and how we are actually doing motion sensing, and how it actually benefits the excavator operators. Then I will move on forward to actually show what is the how we can actually use our systems to do more automation for the excavator operator. Okay, I guess that explained everything. Okay, just to recap a bit. So, what the idea is that using our current setup, and by adding a couple of components, we can actually add the automation level of the excavator. So we will still have the G2 IMUs in the frame and the bucket and the arm and so on. To actually get the kinematic chain, we will still have the Gnss pole to actually get the position, but what we will add is the automation unit which will be connected to the ECU of the excavator. And then through that we can actually get the sensor information of the pressures, of the locations of the sensors and so on, and we can control the hydraulic valves. So basically after that part we have control over the excavator. At some times we also might need to add the rotation encoder between the frame and the undercarriage in some cases. Just to give you an example what this actually means and what we can actually do with it. this works. Nope. Okay, well, that won't play. But the idea is that we can actually, for example, automate the grading of leveled surface, which is actually, it sounds quite easy, but there are actually quite many moving parts in the excavator, and the excavator operator needs to manually control each of them. So basically, by manually controlling each of the joints, the excavator operator would need to make leveled surface for the whole amount of the grading that he needs to do. With our system, we can basically just set the level that what kind of level we actually want to make, and in what kind of angle we want to actually grade that level. And that would actually just give us a perfectly leveled surface each time. So it basically helps the excavator operator quite a lot by removing the extra work that he needs to do. And especially for new excavator operators, this can be quite challenging. Of course, with more experience, the excavator operators can get quite handy with those machines, but especially for newcomers, this can be a quite difficult task. Other possibilities can include, for example, swinging limits or different kind of limits. For example, in tight spaces, in cities where there is not that much space, we can limit the amount of the workspace where the excavator operator can actually work in. That way we can make sure that the inexperienced operator, for example, won't hit the opposite building or something like that. So these are currently under development. And just to give you also a quick information where we are actually heading also in the future. So these are the steps of technology on how we actually see it. So everything starts up from the manual work process into mechanical work and so on. And in the information stage, we actually start gathering information of the whole environment in digitalized form. That basically gives us tools for aiding, giving assisted features for the excavator operator. And from there, we can go on to actually doing automatic sequences, which is basically what where we are currently. So basically, we can do automatic sequences such as grading or something like that. Next steps would include the actual remote operation. So the excavator operator wouldn't need to be at the location anymore, but he can be somewhere else. Then the machines would actually do even more automatic tasks. They wouldn't be, the human wouldn't actually need to press any buttons anymore to actually make anything move automatic. Autonomous actually means that the individual excavator is fully autonomous, and then the final step is that the individual excavators are actually cooperating between themselves, so there is no human intervention actually needed anywhere anymore. So those are basically the plans, how we see that the future technology is developing. About the demonstrations, I will have actually a couple demonstrations. I have a G2 IMU sensor that you can play around with. I will connect it with my computer, and you can basically see the information that it produces and how fast it is and so on, and we can discuss it further over there. But then I will also have a fully functional demo setup of our Excite Pro device, which also has simulated boom. So we can actually move the boom by hand, and we can see how it actually moves on the screen for the excavator operator. And we can see some 3D models also on the screen. Okay, yeah, that's about it.
Okay.